Hi there. Today we're going to kind of expand on what we did yesterday. Yesterday we had parallel lines and we were showing angle relationships. Today it's the other way around. We're going to have some sort of angle relationships and we're going to prove that the lines are parallel. Ultimately it's just the converse of all the theorems we had yesterday. Here's what I mean. So I'm going to have a scenario where I have this picture. And it's going to have these two lines and this transversal, but notice on this one that the two lines don't have the little triangle. The lines are not parallel. What I do know, though, is that these two angles are congruent. That's what's given to me. Oh, okay. Well, what kind of angles are those? Do you remember that angle pair name? Okay, they're both in the upper right. They're in corresponding positions. Those are corresponding angles. And if the corresponding angles are congruent, well, that only happens if the lines are parallel. So it's the converse of the theorem we had yesterday. Now it's going to be if the angles are congruent, then the lines are parallel. The title of this section is Proving Lines Parallel, and we're going to use all of those theorems to be able to do it. Well, we're using all the converse of those theorems. So it works for all of them. So here's the corresponding angles. If the corresponding angles are congruent, then the lines are parallel. If the alternate interior angles are congruent, then the lines are parallel. If same side interior angles are supplementary, then the lines are parallel. And if alternate exterior angles are congruent, then the lines are parallel. This is what the problems are going to look like for us today. It's going to look like this, and again, notice that there's no triangle on these lines. So right now, I do not assume that there's any special relationships because these lines are not parallel. But the question says, what is the value of x for which A would be parallel to B? Okay, well, if I want A to be parallel to B, then these are same side interior angles, and I would need them to be supplementary. All right, so here we go. I am going to set them then, or add them up and set them equal to 180, because that's what would have to happen for A to be parallel to B. All right, so I get 2x plus 120. If I subtract 120 on both sides, I'm going to get 60, and divide by 2, I get 30. That's the value of x that would make A parallel to B. Kind of the same thing, they're just wording it differently. All right, so you try this one. Figure out what W would have to equal so that C would stay parallel to D. Go ahead and pause the video and try this one on your own. All right, this is what I got. Did you catch that this time you're dealing with corresponding angles, and you would want corresponding angles to be congruent, not supplementary. So we're setting these equal to each other this time, not adding them up and setting them equal to 180. All right, so you kind of have to remember which ones are supplementary and which ones are congruent. All right. Let's look at this and let's make it a little crazier of a picture. Which lines or segments are parallel? All right, so they're showing us some sort of an angle congruence, and we got to figure out which lines that would make parallel. All right, so to do this, I think it helps if you highlight the lines that create the angles. So when I look at angle G, it uses this line and this line to create angle G. And then to create angle E, I use that existing line I just drew and this one. And when you draw that all out, then it's pretty obvious to see, oh, there's my parallel lines, and there's my transversal right there. So when it asks me which lines are parallel, I'm going to say line BE is parallel to line CG. All right, let's try again. Let's come over here and look at number 8. All right, again, I'm going to highlight the lines that are used to create those congruent angles. So one of the lines is this one to create P, and then this line. Together those create P. And for Q, it was the first line I drew. That's going to make that the transversal. The transversal is the one that gets used twice. And then right here. And then when you draw that, you can say, okay, then that would make line PS. Oh, I didn't draw that very good up there. Parallel, parallel. Okay, and then parallel, one of my lines didn't show up. Okay, parallel to line QT. All right, why don't you see if you can do the next two on your own. Highlight them if you need to, or just use your pencil to draw over it really bold, something so you can see which lines would end up being parallel. Pause the video. All right, how'd you do? Check my answers with yours. See if you agree. All right, and that leads us into being able to do a proof with these 4 new theorems that we have. All right, so this time, we're going to be given some sort of angle relationship. We're trying to prove the lines are parallel. This has several steps to it, so write little here. All right, and I'm going to start right off the bat with just putting in my given information. So I'm going to say angle 1 and angle 3 are supplementary, and that's just given. You're filling this in with me. Okay. Now, what do you do from that? Notice in the picture there's no parallel lines. There's no little triangles. So I can't do anything there. So I'm really working with my angles. I guess the only thing I have left is if angle 1 and 3 are supplementary, then I know that the measure of angle 1 plus the measure of angle 3 is going to have to equal 180. Do you know why? Well, it's because they're supplementary. And remember, anytime you say, because that's what they are, that's always a definition. So that's going to be definition of supplementary. Now, I kind of used that up. So I'm going to go to my picture. I'm going to hope that I can find something in my picture. So looking at that, knowing that the lines are not necessarily parallel, I can't do anything with angle 3 there, but I can do stuff with angle 1 and 2 because that doesn't really require parallel lines. Notice that 1 and 2 are a linear pair. Measure of angle 1 plus the measure of angle 2 is going to equal 180. And the reason for that is because a linear pair are supplementary. Now I like the way that goes because look at what I have now. 1 plus 3 equals 180. 1 plus 2 equals 180. Well, the only way that they can both equal 180 is if they equal each other. All right, remember doing that? Measure of angle 1 plus the measure of angle 3 is going to end up equaling the measure of angle 1 plus the measure of angle 2. And that's transitive property. Now, look at what you have here. I got a little bit sloppy there, sorry. But both sides of this have an angle 1 and an angle 1. What if we just got rid of the measure of angle 1? How could we do that? I'd have the measure of angle 3 equals the measure of angle 2, and that's just subtraction. I'm just subtracting that angle 1 on both sides. And then, now I'm ready to look at my picture and look at what I've just figured out. Angle 2 and angle 3 are the same. Well, if those two angles are the same, what type of angles are they? All right, they are corresponding, and if my corresponding angles are congruent, then my lines are going to be parallel. That's my new theorem. If the angles are congruent, okay. Now, the one thing I might do here, and this is me getting really turning into a perfectionist here, if I wanted to change that to angle 3 is congruent to angle 2, by definition of congruent, I can do that because the theorem does talk about congruent, not equal. But if you skipped that step, I wouldn't count off on that. But the book probably would like that. Now, so if those two angles are congruent, so then I think I'm ready to jump into my proof statement. I think line A would be parallel to line B. And my reason is my new theorem, if, now yesterday everything was if parallel lines cut by a transversal. That's not my if. If corresponding angles are congruent, then the lines are parallel. That's how I follow it up. That's my then statement now. I switch it around. It's the converse. All right, what you think? Can you do that? The answer is yes. Say yes, I can do that. Now go do it. Good luck.